In this lesson, we will be teaching you how to solve quadratic equations. So there are two methods. The first one is by factoring. The second method is by completing the square. So in this lesson, we will first talk about how to solve quadratic equations by factoring. So let's do some revision that I have taught before. So the quadratic equation form is ax squared plus bx plus c equals to 0, where a does not equal to 0. So now let us solve the equation x squared plus 5x plus 6 equals to 0 for x by factoring. Step 1, we have to rewrite x squared plus 5x plus 6 as a product of two first-degree polynomials. So x squared plus 5x plus 6 will equal to open brackets x plus 2 close brackets times open brackets x plus 3 close brackets. So our second step is to solve equation open brackets x plus 2 close brackets times open brackets x plus 3 close brackets, which is equal to 0. Since the equation is telling us that x plus 2 is equal to 0 and x plus 3 is equal to 0 too. So there are two possibilities. X equals to negative 2 or x equals to negative 3. Thus, there are two solutions, x equals to negative 2 and negative 3 for the quadratic equation x squared plus 5x plus 6 equals to 0. So now let's try another problem. Solve the equation open brackets x plus 1 close brackets times open brackets 2x minus 1 close brackets equal to 14 for x. So our step 1 is to write the equation into standard form, which is ax squared plus bx plus c equals to 0 by expanding the left side. So which we'll get 2x squared plus x minus 15 equals to 0. So our step 2 is to rewrite 2x squared plus x minus 15 as a product of two first-degree polynomials, which we will get open brackets 2x minus 5 close brackets times open brackets x plus 3 close brackets. So the last step is to solve the quadratic equation. The 2x minus 5 equals to 0, x equals to 5 over 2, or x plus 3 equals to 0, x equals to negative 3. Thus, there are two solutions, x equals to 5 over 2 and negative 3 for the equation. Solving quadratic equations by factoring may look simple, but there are still some disadvantages. So the biggest disadvantage for finding the unknown by factoring is it highly depends on the possibility of finding factors of first-degree polynomial with integer coefficients, and this is not always possible. For example, x squared plus x minus 7 equals to 0. So now I'm going to introduce you a more general way of solving quadratic equations, which applies to all quadratic equations. So the method is that by completing the square. So this time we'll try to solve the quadratic equation x squared plus 5x plus 6 equals to 0 for x by completing the square. So step 1 is that we will rewrite quadratic equation such that the constant term is on one side of the equation. So x squared plus 5x will equal to negative 6. So step 2 is that we may rewrite the left side of the equation as follows. X squared plus 5x equals to negative 6, and then to open brackets x plus 5 over 2, close brackets, square, equals to 1 over 4. So the last step is to solve the equation. So we will get x equals to -2 and x equals to -3 for the answer. So after talking about how we can solve quadratic equations, we'll now talk about the quadratic formula. So previously, we have taught how to solve quadratic equations by completing the square. And today, we are going to solve quadratic equation ax squared plus bx plus c equals to 0. And let's start now. So we have to rewrite the equation in step 1. So what we need to do for step 2 is that we have to rewrite the left side of the equation so that we can apply the identity a squared plus 2ab plus b squared equals to open bracket a plus b close bracket square, which we will get open bracket x plus b over 2a close brackets square equals to -2 over a plus square of open brackets b over 2a close brackets. So our last step is to solve the equation. Since to save some time, so I've went on the web to look for the solved equation. So x is equal to -b over 2a plus or minus square root of b square minus 4ac over 2a. So the solution for ax squared plus bx plus c equals to 0 is also called the quadratic formula. So let us try a problem. Solve the equation 5x squared plus 14x minus 9 equal to 0 by using the quadratic formula. Since the equation is already in the standard form, ax plus bx plus c, so we can immediately substitute a equals to 5, b equals to 14, and c equals to -9 into the quadratic formula. -b plus or minus square root of b squared minus 4ac over 2a. Thus, the solution for this question is x equals to -7 plus square root of 94 over 5 and -7 minus square root of 94 over 5. After solving a problem, let us discuss the number of solutions of a quadratic formula. A quadratic equation can have 0, 1, or 2 solutions. These 3 possibilities can be seen by examining the quadratic formula -b plus or minus square root of b squared minus 4ac over 2a. The number of solutions is determined by the expression b squared minus 4ac, which is under the square root sign. Because the importance of this expression, we call it the discriminant. Case 1. If the discriminant is positive, which is b squared minus 4ac is larger than 0, then square root of b squared minus 4ac must also be larger than 0. Therefore, -b plus square root of b squared minus 4ac over 2a and -b minus square root of b squared minus 4ac over 2a must be 2 distinct solutions on the number line. Case 2. If the discriminant is 0, which is b squared minus 4ac equals to 0, then there is only one solution on the number line, which is -b plus or minus square root of b squared minus 4ac over 2a equals to negative b plus or minus 0 over 2a, which is equal to negative b over 2a. Case 3. If the discriminant is negative, which is b squared minus 4ac is smaller than 0, then clearly the square root of b squared minus 4ac does not exist. And for case 3, we will also explore and teach it in the lesson of complex numbers. So let's do a quick summary. The quadratic equation ax squared plus bx plus c equals to 0, where a does not equal to 0, b and c are any numbers on the number line, has two solutions on the number line if b squared minus 4ac is larger than 0, has only one solution on the number line if b squared minus 4ac is equal to 0, has no solution on the number line if b squared minus 4ac is smaller than 0.